Welcome all, and today's session is near and dear to me, which has to do with architectural thinking. So certain things I'm going to discuss here would be looking at from the principal perspective. How do you need to make sure that you create the architecture which really works for your situation? So what are we going to discuss? We're going to talk about architecture characteristics. What does architect does? How can we leverage from what are the responsibilities given to an architect? Then we will look at out-of-the-box thinking. And when I say out-of-the-box thinking, I'm going to challenge it also, saying that sometimes out-of-the-box thinking is not good. Okay? And that will make you think differently. That's what I want from this session for everybody to do. Then we look at from the paradox of choice. You have plethora of choices. There are a lot of technologies available. Which technology to pick? And people ask, like yesterday somebody asked a question saying that, hey, from cloud technologies, which would be the holy grail technology which will work for solve all the problems? There is none which does that. But I'm going to talk about how do we approach this as a whole. Then we look at technological principles, like what are the different concerns which we have while building a particular architecture. And in the end, we'll look at how do you project yourself? How do you look in the future and project yourself? So those are the things we're going to discuss. I hope you like all of our talks here. So from the expectation perspective, what do? Architects, they define an architecture. They make sure that the design principles are being maintained. Quality attributes you have got. You apply all the constraints given to you. Product owners, you go to the product owner, they give you the requirements, and based on those requirements, you go in and solve that requirement, okay? Make some decisions at the end. So basically what you're doing, it's an art. You start drawing and you are trying to finish up the picture, but it's not fully there yet. Isn't that the same thing what architects does? You have been given a problem to solve, and you have been asked, like, hey, how much it will cost us? We just say that, okay, maybe it will cost me like 30 man days. Or maybe take 50 days to finish this work. But we start with some kind of an understanding, what's our art looks like. And we look at a problem. So, let me try to understand. Customer is asking, I want this, I want this, I want this. Do they really want that? What is their need state? That's what the architecture is all about. Architects have to understand what are their needs, customers' needs. So for that, you have to pick the right choice. You have been given different options, pick the right one. That is the choice which is going to help your company move forward really well. So what we repeatedly do, excellence then is not an act but a habit, Aristotle. So what he's saying that it's not an act. It's a habit, how we do daily routine, how we conduct ourselves in our office, and what strategies we need to do. So that's what we're going to discuss today. So what are the strategies? What are the things which we do? Oh, we look at product understanding. Then we say that, hey, how much time it will take to finish this product. We look at the usability. We look at the software. We do development. We look at the QA programming aspect of it also. So it's not like just one thing. But it's like the overall understanding, breadth of understanding what needs to be done. So if you look at all these things here, from the architecture perspective, you have to look at two things. One is what you know. You need to be good at it. One is what you know you don't know. That's still okay, but you know some people who know that. What is which you don't know at all? And you also don't know that you don't know. So you have to find out. So on this talk, whatever technologies I'm going to discuss with you, go back, research on those technologies, and increase your breadth of knowledge. Because that's going to really help you grow in your understanding. So what are we trying to do? From the stakeholders, we get the requirements, we get constraints. Hey, you have to solve it in $100,000. Then the architect comes with the principles. We'll discuss some of those principles Find out from the community experience, which you are here to find out what are the patterns, what are the anti-patterns for solving a problem. You are attending so many of the lectures today. And then we come up with an architect at the end with respect to the technology which we are trying to build. So what it means when I'm looking at a picture, if you see, everybody has got, from a company's perspective, an architect is looking only the trunk part of it. Some looking at the tail, some looking at, you have to come a little bit, look at from a distance, and then look at this picture. Oh, we're trying to understand an elephant. And then what happens, then there is a synergies which comes in. Oh, you know what? You're trying to solve this problem. Maybe I have the same problem. Oh, maybe we should correlate, trying to solve the same problem. Oh, you know what? We have to understand how we are going to move ahead. All those things come in when you take back and then and then you try to analyze your results. So that's the key part here. That's where the out-of-the-box thinking comes in. And we all say that out-of-the-box thinking is really good because what you're doing is you're not trying to solve the problem just by somebody gave you something and you started solving it. You're asking questions. With out-of-the-box thinking, one of the things you want to do is 5 whys. Ask the same question 5 times. Why do you need this product? Why is it really needed? Why the customer is really asking for this solution? Why can't they solve this problem with existing software? When you ask 5 whys, you will actually get to the root of the problem. And then that way you can really solve it. So how do you do out-of-the-box thinking? Anybody? So what we do is, one is we know Java. I already know Java. I am very good at it. I'll really be good at Java. But no, learn another language. Okay? Pick any language. Doesn't matter. Scala, you pick, if you know Scala, then pick Python or pick any language. Try to read that language. Understand that language. Because the similes really help solve the problems. It's not what we are doing all the time, but observing and then solving that problem. And of course, you want to discuss. You're not just thinking about yourself and keeping it to yourself. You're going to discuss within the team. And you're going to collaborate. When you collaborate, what happens? You have a problem, you go and talk to another person. Hey, this is what the problem I got. What do I do in this case? What do you think I should do? Oh, the person have not even responded. And you say, oh, I know how to solve this now. So what happens is that thinking process of asking questions and then getting the answer really helps you drive this. So let me ask you a question. Somebody asks you that with 3 straight lines, you want to cover all these dots, all 9 dots. How are we going to do that? Huh? Yep, I can do 1, 2, 3, 4, 5. There can be many ways to do that. I mean, there is one problem like this, like 1, 2, and maybe 3. I don't know. There could be, but only 3 straight lines to solve this problem. How about this? Yeah, that is out-of-the-box thinking. That is going and saying, oh, you know what, I can solve this problem by this way. But maybe there is a problem in this. That's one way of solving it. That you can do by learning other languages and trying to resolve that particular problem which you're trying to do here. But there are other ways to really get that thing done. So what do? You start thinking. Here's where you're thinking. Ask the question. What did I say? 5 whys. You ask 5 whys to the product owner. Say, how about I think differently. I got a problem. I tell my solution to another problem. This is called lateral thinking. Lateral thinking means that you tell some solution to another person, you generate ideas from another people, and then you come up with a light bulb or a holy grail to solve a particular problem. That's the thinking which you want to really create within the organization. So organization needs to really map it through. So the traditional thinking, this is the out-of-the-box thinking, is that, oh, you start from here, you finish till B. Lateral thinking is saying, oh, I want to go from A to B, just go from outside. and ask the product owner, would that solve your problem? Say, yeah, that'll solve my problem. Okay, that's asking 5 whys. That's going to solve a lot of time which takes you. Another problem which is there, in this situation, I got 1 line. It doesn't matter, you got 1 line to solve this problem. Simple. And you don't even need 3 lines. The width of the line is more. Okay, that solves this problem. How about another way to solve, like, what we can say circular. Like, nobody says that, it has to be, exactly straight. So you ask this question and then get an answer from there. So that's going to give you a good understanding. So 2 ways of thinking. One is out-of-the-box thinking, another is lateral thinking. Those 2 thinkings is going to really help you drive. And hey, the third one is that, hey, you just move. It doesn't need to be a straight line. Come on. It's like, it's just asking different questions and then that's getting you the better answer for you. So what's really happening is, what architecture is doing, they are trying to create a picture. And you're trying to create a magnificent picture where you're turning the page. When you're turning the page, you want to make sure it's detailed. When you're doing this, you're actually discovering. Isn't that called discovery? In our agile terms, we do a discovery of a particular product. This, I'm doing a discovery here. I think, okay, I want to have this side, this landscape looks like, this is the house, and this is the way I'm going to build it. It's not built yet, but that's the key part. You have to get the discovery done before you start the project. So that's kind of like, if you have 80% confidence of starting a project, yes, now you're ready to start the project. That's part of the discovery process which you want to achieve. You want to know what your end goal is. If you don't know where you're running, if you're running with a football, you need to know which part you're running. You don't want to run around and trying to, people have meetings over meetings over meetings, but they don't know really what they're really solving. So when you ask the questions correctly, then you solve the real problems. So what is your script? Find out what is the script looks like. That means you find out how they need to solve that particular problem. Now, another thing from architecture perspective is that you always look for the valleys. They are the golden nuggets. Okay. So when I look at this beautiful picture, and there is a bridge here going in, you know what happened? Architect came in, or developer came in, they found out that in order to go from this place to this place, people always have to go down, hop over this, and then Control-C, Control-V, Control-C, Control-V, and then come to this part. So what you're really looking for is places to automate. So this is where the automation comes in. You create a project, and then you submit this project out. Now everybody is going in a freeway. That's the perspective you need to have. You need to go in a freeway. Create freeway within your company. That's going to get you real bang for the buck. And that's where the paradox of choice comes in, where less is more. You don't want to do a lot to solve a problem. You want to pick like 2 technologies maximum to solve it. What happens is that you need to pick the right technology. Skills have to be right, like, okay, if you use this or you use this, like depending upon what you really want to do. You want to pick the right technology to solve this particular problem which you have got. And pick the right skills, what skill sets, team, what you're trying to build based on that. So what happens if you have many choices? So if the number of choices increases, then the net feeling goes down. So when you present your ideas, you have maximum 2 choices to present, and that is actually a norm. Like, you don't want to present like 5, 6 ideas and say, hey, somebody else choose for me. As part of the architecture, you have to present this and choose it. So from the technical breadth perspective, if you think about it, I think I was talking about it before that, this is what you know really well. Okay? Stuff you know you don't know. This is the technical breadth you're increasing. What I am suggesting you is you go pull this down. And also stuff you don't know, you don't know. So if you come into this territory, it's going to really help you bring in the similes. You're trying to solve a problem, you can bring in similes to solve the problem for you. And that's where the estimation comes in. Because once you have got a similar kind of problem people have solved, you know that you talk to them, then you can say, okay, maybe it's going to cost me around 50 days to finish this project. Get the estimation done for that particular project. And then you have to build the right team. You have to pick the right team. What is this team means? That's your inner circle. Okay? What do you mean by inner circle? One is your office, when you're working with. One is, what does your network look like? If you have a problem, if somebody is an expert, do you know all the experts within your company, within your team? So that's where you can go and find those things out. And then what you're looking at it from the glass, and you're planning yourself. You're planning your process. So the planning process basically takes place is that you got a problem, you got a situation you want to solve, and then you talk to the team and get the answers from them, do the out-of-the-box thinking, and resolve what you're trying to do. And that's where you have to now give your presentation. The presentation is very key, and that's where you want to first find out from project management, from the product management, and from the architecture management, you have to talk to many stakeholders. And while talking to them, and then you have to convey your idea, whatever you got, and everybody has to understand what you're trying to do. Then it makes it a success for you. So another thing is that you have to holistically look at a problem, analyze it. If you cannot analyze that problem, like sometime what happens, you don't understand it fully, and that causes confusion. Till the time you have a full understanding of a problem, the Steve Jobs says the same thing, till the time you fully understand a particular problem, you have to really nail it down. You have to understand it end to end, then try to solve that. So that's what this is saying. So what all things we need to do? From the skills perspective, what you need to do is you have to make sure that you motivate the team, communicate with them well, and influence with the decision making. So this is the part which you want to influence. And how can you influence? By making sure that you negotiate and you build your trust. If you don't build the trust, it won't help you, because you have to convey your ideas to people. And this is the key part. I have done the study on this one. Only 15% of technical knowledge is really needed. If you want to grow up, 15% is needed. 85% of the knowledge is emotional intelligence. That's the most important thing. And that's going to give you across conflict resolution and help you more on the leadership skills which you need to have. So if we are together, nothing is impossible. But if we are divided, we all fail. So important thing is to make sure we have the team work. You're working with the product manager and QA skills to really make this happen. So how do you present your idea to the stakeholders? That's the key part. Like sometimes, how many times you get an email, and that email you're trying to resolve, and you don't really understand what's really going on with that email? How many have that same problem? So what really happening is they never gave you context. They just started, so some problem is there, and somewhere in the middle you understand, what the problem is. So instead of that, if you build a culture of something called situation, scrap, we basically first describe the situation, what is the really context you are trying to solve. Say that, okay, we found out that the performance is not good because under load, it works perfectly fine on 5 concurrent users, but if we tested it out with 50 concurrent users, there is a problem. So define the problem after that. That's called compilation of a particular problem. Then what you need to do? Then you need to find out a resolution. Then you say, okay, this is the resolution. These are the 2 alternatives, and I recommend one of the alternative out of this. Or ask a question at the end. And what is the action? If there is no action, that email you can put in the trash. There is no use of it. And at the end, what is the action plan which you are trying to ask for? If you do it this way, the email, not only just the email, but any presentation you are giving, any 3 or 4 slide or 5 slide you are creating, if you have this way logically made, if you present it to the management, it'll get more traction because you are giving all the details what you really need here. Then comes IDEO. IDEO is a great way, and this will give you the bang for the buck for coming here also. Like, it'll give you an understanding what's really going on. So IDEO is, how many here know about IDEO? Okay. So what they do is they observe. They are observing how the customer is using stuff. Just like Steve Jobs, he observed. He actually observed and say that, hey, kids are coming in and watching a movie. Kids are going in and buying the whole CD and only listening to one song. He did iTunes. That's the same thing with this one. So what we are trying to do is we are trying to build this framework to really get that thing done. So let me just try to start it up. 1 second, starting.
We weren't sure quite what he was. Was he an architect? Was he a designer? Was he a filmmaker? But what he was, obviously, was something we all wanted to be.
She made paintings out of what she was surrounded by. Everything she touched, she turned into something magical.
For them, these names like painter and architect, they weren't job descriptions. They were ways of looking at the world.
Modern design was born from the marriage of art and industry. The Eames office was born from the marriage of Ray Kaiser, a painter who rarely painted, and Charles Eames, an architecture school dropout who never got his license.
They give shape to America's 20th century.
And it all began with a chair.
Had they just designed the furniture, they'd be in the pantheon. It's the multifaceted nature of the career that is extraordinary.
For 4 decades, 901 Washington Boulevard in Venice Beach, California, was one of the most creative addresses on earth. Westinghouse, Boeing, and Polaroid all trusted the Eames office to solve their problems.
They wanted to work for the Google of their time, and they did.
They were introducing people to look at the world differently. Life was fun, was work, was fun, was life.
Dozens of gifted young designers cut their teeth within the walls of the studio.
I walk in the Eames office, and it was like walking into a circus.
And I thought, I've come to work in Disneyland.
It was a career that defined what it means to be a designer. Perhaps the greatest Eames design of all was the image of Charles and Ray. Together, they would become one of the great success stories of the post-war era.
So this is exactly what I'm talking about. Once you start thinking differently about the world, because if you start doing the same things again and again, what he's doing, he was a painter, he was a designer for a particular problem which is given to him. He was designing chairs, he was designing Boeing, he was designing different areas. So that's the next step which we're going to do, is to think differently. All these problems you have to think differently and solve it at this point. All the truths are easy and understand once, and they are discovered to the point of the discovery. So what it really means is you have to first understand your customer. And that is the key. Understand the business and the market. These things are really critical. So how many here are business analysts, or they know business analyst? So what happens is that even if you are an architect, even if you are in a technical area, you have to go in depth into business of your customer. If you don't do that, you won't really know what the real problem is. So that's what this is talking about. Like, you have to understand all 3 things. You have to understand the market and ask the questions, 5 whys, to really get this thing going. What are the pain points? Ask them, what are your pain points? And how you make yourself more efficient. When you're solving a problem, how can I make yourself more efficient? And you're looking for a need state, what you're trying to build at the end. So basically you have a dream. You are trying to build a dream. Architecture is a drawer of dreams. You're dreaming and making this possible. So let's look at ISO 9126. So what is ISO 9126? What it gives you a clear understanding how do we design a particular software. So let's start with the reliability. Are you building your software which is fault tolerant and which has a maturity level given to them? Are you doing the portability correctly? So that's another question which you can ask yourself, saying that are you adaptable? Are there new requirements coming in which you're going to build on top of a particular framework which you're trying to create? What's the efficiency? How is your resource utilization? That's the key part. Maybe not all your processes need to run at the same time. And that's exactly what a lot of companies are doing right now. What they're doing is, if you think about it, they are making sure that whatever the heuristics they are running, they are not running at the time of the peak load. When they have a peak load, they're utilization, their maximum utilization, 80% capacity, they are doing it. And how they are able to do that? They run the batch which they need to run to do the analytics part at the time when you can wait for some time and do that. That's the key part here. That's where resource utilization is very important for you. How's the maintainability? If you get a problem, now you're a distributed system, distributed system means like from a cell phone, some person clicks a button, it goes through a lot of layers before it goes through the database. And then when it goes through the database, it goes through analytics. That means you're streaming the data out and then getting the results. So that's where the maintainability comes in. And usability, is another thing which is there. How many here have used gestures? Gestures in there. So you can use gestures and solve a particular by doing certain way. Your product support those gestures. Accessibility is a big thing which is coming in for us. And what functionality which you're trying to provide, like security aspect of it. So I would encourage you to look at the ISO 9126, to look at the compliance model. The important thing is that you're asking yourself, the product owner, what kind of availability you're looking for. If you say here 99.99% available, that means 52 minutes of downtime. That means only 5 minutes of downtimes per month. 5 minutes of downtime. It's pretty hard to achieve that. But you can achieve it with the technologies given to you, like cloud technologies are there, which enables you to do this. With fault tolerance and failover strategies, you should be able to achieve this load. Another thing is reliability. What the reliability means, it's mean time to failures. So what is mean time to failures? That means the total lapse time minus the sum of the total downtime which is given. So you have to find out what is the mean time to failure is. How reliable is your system? That's the key part here saying. Another thing you have to see is that mean time to repair, MTTR. Why do you need to worry about this? Because of SOC 2 compliance. If you are working on SOC 2 compliance, the important thing you are looking for is data loss. How many here have strategies for data loss? When you have a data which is there, you should have a data strategy, which if something goes wrong, now data loss within your system is one thing, but when you are sending data from one system to another system which is a partner, and while sending they received it, but their system goes down. Okay, how to make sure that you are able to repair within 8 hours? How are you going to resend the same data? Create an audit log and find out what's really changed in the past 10 hours or a month or 2 months, and then resend that same data out. That's the key part which you're trying to say here. Another thing is that this is the TUB model which is there. You get the failure rate before, but then after that, whenever there is an upgrade, there is a disstability which comes in. You want to make sure that this disstability is not a lot of you're not unstabling this system. So that's the gradual upgrade process which is going to give us more of the view of the failure which are happening in the system. Another thing which is important is how linear the system is. Now this is the Netflix example. This is for Cassandra nodes, which is there. So Netflix, these are number of client writes versus the node counts. If the node count increases, that means millions of users are watching the movies, the response is linear. That's the key part. That's exactly what you're looking for. So it's possible using Cassandra, it's possible using the technologies which are available, Netflix technologies which you can use to do this. Another thing is the notification warnings. How many here get warnings if there is utilization more than 80% or 90%? What do you need to do? How do you need to self-heal? That's the key part. You're asking this question to yourself. You have to self-heal yourself. That means you should not get a call at 3 a.m. or 4 a.m. at night saying the system is down and you have to work on it. But system should automatically heal itself and be able to respond to the messages and perform really well. So another thing is extensibility. When you're building a system, you're just building this right now. But is this extensible enough so I can build other modules on top of it? That's the key part which you're asking. Are these swim lanes which I'm building? That means if I add new modules, they are built independent of each other. That's the question which we are asking in the extensibility model. Another thing is adaptability. Now when I say adaptability, we build this. But can this fit into this newer place I'm visiting? Not really. What do I need to do? I need to build with adaptability in mind, where I can support both types of models. Like Europe has a different model, America has a different model, and as well as India has a different model. But there are switches available which can support all three of them. That's the thing which you are asking for. That's the industry standard. If you try to comply with the industry standards and use open source technologies, that's going to help you make sure you make the right decisions for this. And that's where the compatibility comes in. So important thing is you don't want to break anyone. And give some time for the old versioning to be removed. Okay? And you always must version your APIs. We are all in API first world, mobile first world, API first world. And for doing that, you want to make sure you support the old versions of the APIs too. And there should be a versioning strategy. And then I had a tweet just now where I did talk about, I have a podcast, 2 podcasts are there, which talks about how do we make sure that we do the compatibility and how do we do the best practices for APIs. So you can look at my tweet from today and look at the 2 podcasts, which will be good. Good understanding on how do we do this. Another one is that you're trying to find out what's the flow looks like. You create your own flow. How the ideas are generated within your company, how the designs are taking place. And of course, this is talking about the different factories and it's coming around. Isn't it the same thing for us? We have our own company's business flow, which is similar to a tire factory, in this case, the body plant, you're building a car here. You have to know what the flow looks like. And all these flows, when you're making a flow from here, this is actually done through something called Integration Hub, iHub. How many here have iHub? Integration Hub technologies. So what happens in case of Integration Hub is, when I'm trying to connect from the body plant here toward the assembly plant, how many cars needs to go in from here till here, I can ask for 20 of these cars at a time. That's my capacity. I don't want more than this. That's my service limit. How many here have service limit for their APIs? No one does that, which is the problem. So what you need to do is write it down, service limits. You want to find out how much data I need to return back. I'm always talking about 500 milliseconds of response time, but really, does it make sense to be 500 milliseconds of response time? Because if you don't have a service limit, let's say you are asking for 10 customers and you're asking for 10 days. 10 customers, 10 days, that's, or 100 days. That's fine, that's 1,000. 1,000 total is the service limit, let's say, for a given API. Instead of 10 customers, you're asking for 100 customers. So how many days you should be able to ask for? 10 days. So make it as a service limits. Now you may ask that, hey, how this plant will be able to serve other plants which are coming through? What they can do is they can provide this service limit. They can batch the process. When they're sending the values from here to here, they're batching it. They're not sending it right away. That's the key part. That's the part of the design which you want to keep in mind from the architecture perspective, that you are still satisfying. So how they can serve it now? Because you have a service limit of 1,000, what they can chunk the number of customers they are asking for. They can ask in parallel. So that way it's still the better way of doing that. Make sense? So that's where the architectural perspective is. To design something really well, you have to get it. You have to really grok what it's about. It takes a passionate commitment to really thoroughly understand something and chew it up and not quickly swallow it. So we don't need to swallow, that's the key part. And that's where the vision comes in. You have to provide a good vision to solve a particular problem. What are the principles which are there? The number one principle is least surprise. Don't surprise your customers. Don't really surprise your customers. And law of Demeter. So where you're trying to minimize your dependencies. What are the dependencies which you have got? How to break these dependencies? So what you're trying to do is what's the loose coupling? Like you're more interdependency. You want to be somewhere in the middle, like somewhere here, where you are you're not tightly coupled also, and also you're not totally loosely coupled. So somewhere in the middle you can be here. So this is an example of JDK 1.5. There are 1315 classes are there, and 229 packages. They're all connected to each other. And they are moving away from this with Java 9, and where they have different component modules, the 3 different types of components, and that's going to really help solve this particular problem of deploying it. Principle of least effort, where you don't want to put a lot of effort to solve a problem. You want to look at industry standards and find out what's the outcome is. You want to put the least amount of effort to solve a particular problem. Now, principle of opportunity cost is that you have chosen this nice sun, and this is the direction you are going in. There is an opportunity cost. You are missing out another sun on the other side, or you are missing out on a moon site. But you are really focused to get this thing done. That's the key part which we have to understand here. So, of course, you working late at night. You're very sleepy, so you see lost cost is your sleep at night. That's the key part which you're looking for. Principle of single responsibility. What happens when we're trying to build our classes? What we do, we say, let me solve all the problems which is given to us. Not a good idea. Not a good idea anymore. And that's something which causes problem. Hey, I want reuse of my component again and again. People say that. It's perfectly fine to be duplicate code. There is no problem in that if it is componentized. If it is swim lane, that means within a swim lane, it's working as an independent component. Because now you can, because you're not dependent upon anybody else. That's the key part which is there. Plus, you should solve only one problem and solve it really well. That's the key here. Principle of simplicity. You want to make sure you use the right tools, simple tools to solve a particular problem. So it really helps in development. When we are developing software, it reduces the time to market. Like when you are deploying your products, you should be able to deploy it faster in this case. Principle of last responsible movement. So you want to wait. So you say, why should I wait if I have to solve a particular problem? Why can't I do the whole discovery now? If your project is starting in 6 months, you might want to wait for till the time when you have to make that decision. That's the key part here. From architecture perspective, you don't want to make a decision right away, but wait till the time. You ask hey, till when I have time to make a decision? That will give you a good understanding how to solve that problem. You have a good customer understanding before you do this. Another thing is the feedback. Agile, we are all in the agile world. We want to make sure we understand the customer's requirement And then because we understand the requirements well, get the feedback from them and resolve this thing. And this is the agile principles. You gauge yourself, just like the agile principle, you gauge yourself saying that, hey, are we able self-organizing team or not? Maybe we need to work on this. Focus on simplicity, yes, we are doing really good here. Technical excellence, maybe we need to put more conferences and get more information what's coming in. So you find out where is your radar looks like. And I'm going to talk about the radar in a second. Technology, like what technology to pick in 5 minutes, I'm going to talk about it. But this is going to give you a gauge. Create your own gauge. What technologies I need to work on, okay? And just focus on those technologies because you're increasing your breadth of the knowledge. Another thing is developer productivity. When I am talking about productivity, it means that, you see this here, there is a procrastination is also strategizing, overhead. So all these places we are spending time, we have to see, what is the real place where we need to spend the time to be more productive here. So that's where the architectural concerns comes in, like, where you're looking through from the glass and you say that, hey, I got some kind of a checklist model. So what we do is, and that was a real problem before, like also. So Atul, he came up with a checklist. So what happens is that, did you follow the processes? What happens when I actually went to a place called Destination Imagination, and I was a judge in that. They have written out procedure for anyone joining the team, their team I was joining as a judge, exactly what I need to say, exactly how I am supposed to do, what I'm supposed to do. What happens in your team, you're going to go back in your team, you will find out few people you are dependent upon a lot. So what this is saying is that find out what they're doing, write it down on a piece of paper or in a wiki, exactly how they're doing it. Don't be dependent upon few individuals to solve a particular problem. And that causes a lot of productivity improvements because everybody knows how to solve it. And that's where the checklist comes in for story, where you are finding out, is story being defined correctly? Is it using correct words? And and basically what is my acceptance test for a given story? And then only you start working on it. And so I would suggest you to build your own checklists and then automate them. So if the people have not worked through these checklists, then you can't even promote your code up. So that's the thing you can do here. You always need to have, for a given project, from architecture perspective, you need to define the risks which are there. How many risks are there? What are the assumptions I'm making? What issues I'm trying to fix? And what are the dependencies I got? If you have these for all the projects, that's going to give a key to your project because everybody will know what happens when you are working on a project. You're not specifying what are your risks and assumptions. People say that, hey, I didn't know that this is the assumption which you have got. So that really helps you in the long run. So that's where the governance comes in, where you're looking for no vendor lock-in. So when I lock into this vendor, the vendor rested because there is a rust here. I want to replace this to another vendor. It will be a problem. But if I'm using open source technologies, which are governed, like this same thing happened with us, like, we were using AWS, last year, but we switched to Google. We didn't spend a lot of time, like 15 days we were able to switch the whole company to Google without any problem because we were using open source technologies to really get this going. That's where the open source comes in. But open source backed by the companies who are supporting enterprise backing. So that's the thing which you want to really go for. There are a lot of regulatory compliances here, like the main one is PCI SOC compliant and HIPAA compliant. Those are the three compliance I would recommend you to look at because you want to solve the security aspect of this problem. Principle of least privilege, least authority. So you don't want to give access to your phone number details, all the corporate details, you want to still keep it with yourself. That means if you have a PIN ID number or social security number or some kind of number, it should be encrypted. while moving through the wire. In the APIs also, they should be encrypted. So otherwise, it will cause problems. And of course, you need to do the automation. That's the key part here. Now, when I'm looking at a vision, I'm looking at this bubble, I'm saying, okay, this is what it looks like in the future. This will be another future in 2012, and this is what it looks like, So we need to find out what that future is. That's what we are all here for. We all attend these conferences to find out what's coming linked. So one of the ways you find out is you look at the Gardner technology trends. You can just Google it and get more information on it. So see here, they're talking about 3D printing. 3D printing was really good last year, but right now I have integrated intelligent applications, intelligent trades which are coming in. Virtual reality games are coming in here, so mashing algorithms. So those things are there. So any of these technologies you want to build your breadth in. Internet of Things, for example. This is one way of looking at it. Another way of looking at it is the hype curve. This is a 2016 hype curve from which is there. If you see this, personal analytics. Now when it is going up, this is the time when you need to really understand. Internet IoT platform is coming up right now. Blockchain is there for the security perspective. You need to know how that is working up. So you need to know about these trends which are coming in here and look at these trends and see in your company, are you using smart devices or not? And that's going to give you the breadth of the knowledge. And that's where the bang for the buck is, because if your competitor does this work before you do, then the product can become obsolete pretty easily. So that's where you want to make sure, there is a 4D printing coming in this one, which is actually a hype right now. So let me go over, so ThoughtWorks has something called Technology Radar, which is called Tech Radar. So let me open up quickly, let me show you this. So what happens is that you want to find out what tools to use. I mean, you say that, hey, you're saying that you spend time on this one. What's really going on? So what they do is they have come up with this Technology Radar where you can look at different techniques. So when I'm looking at what are the different techniques which are available for me, it is it gives you a good understanding what's going on with each of these techniques at a given time. Okay, it's coming up. Okay, so these are all the platforms which are there. So if you see this one, okay. So what are the things which are there? Pipeline as a code. I mean, you might need to know what it is to understand what's going on. But if you go on the left side, this is where what are the techniques which are there. So pipeline as a code is adapted right now. But you want to look at APIs as a product. So API is currently built as a product. So this is pretty common nowadays. Like all the companies, if you have a UI right now, which is only your UI and not supported through API, that will be obsolete pretty soon. You have to make sure you have an API first strategy where you're building the APIs, and that will support your mobile devices as well as your desktop devices. That you would need to do that. So legacy in a box. So even if you have a legacy code, like a lot of people ask me a question saying that, hey, I have a legacy app. How do I do that? You Dockerize it. When you Dockerize that legacy app and you have it at runtime, you can take a snapshot of that image. You can take a Docker image at that time, and then it will be available. There won't be any startup cost anymore. So that's the key part which you can really look for. And then serverless architecture. So why do I need to pay money to write my for a Docker image or a VM where whenever I need to execute something, I have a live code and I start executing that code. So that's what it is talking about. If you have a live code, you can do that. Same thing is true with the tools. You can use the tools, different kinds of tools which are available, and you can look at them and say that whichever is in the adopt or trial those things you can really focus and start using them. So what is this saying that, for example, here, Apache Mesos, that's coming up in the trial, which will be adapted pretty soon. So you would need to know about this because with DCOS, all the other products can run within it. So that means if you have a Docker image, if you have Kubernetes, if you have any of the deployment modules, you can run as part of DCOS, which is an open source platform to run it. AWS Lambda is coming up really well because of serverless architecture perspective. Open tracing is there. So if you have a tracing, like currently you have distributed logging going on. Yeah, you can use Zepkins and other multiple tracing tools which are available, but how do I do tracing against a microservice ecosystem? I started from cell phone, I started from one side, and with that transaction, it's going to 100 places and then returning me the value. How do I do that? So that's like open tracing is there. You might want to look at that as part of your vision for this one. Okay, so that's good. So the other thing which you can do is disaster recovery. You have to find out what are the ways you can remove that disaster recovery processes. Next is the languages. So what are the different GitHub languages? As you can see here, JavaScript, Java, Ruby, PHP, Python. These are the 5 languages which are like the number one languages currently available for you. Internet of Things. What are the different Internet of Things which are available? So you can actually find out. Let me show you quickly. So Internet of Things. So if you think about it, overall view of the Internet of Things is like there are billions and billions of Internet of IoT devices are there. How they are interlinking with each other. That's the key part here. What are the different innovations which are available? So when I say innovations, if you think about it, you can build as many innovations as you want. For example, you can have connected cows. So they have one of the innovations was connected cows. That means when you're building your application, all the cows have remote sensors available for them, and they always take their health counters. If anything goes wrong, like if the cow is not feeling healthy, they just remove that cow for the time being from the farm, and that takes care of all the problems from that perspective. So as you can see, there are a lot of players which are there here. And for example, you might have connected homes or healthcare. For each healthcare, how they are associated with each other. So if I go to the healthcare, like any hospital, currently we have heart monitors which are sitting besides me. So a few months back, I went to hospital for my mother-in-law, and then in that case, what happened was that I asked, where is the heart monitor? She's not feeling well. So it's a live streaming going on from the device directly where centralized place a doctor is looking at. So that's going to be the process which is coming in for every one of us moving forward. So what it means is that, and the same thing is true with the biggest breaches. Like you can have different world breaches which could be going on. So for example, and then I have the link also here for that one. So you have to find out how they are getting breached, how are the different elements they are getting breached here. So let me show you that. Okay. So as you can see here, there was the biggest breach of just now the River City Media, and where the backup was allegedly billions of emails were leaked here. Anthem is another one, which is the healthcare provider which got leaked. So now what happened was there was a trend which was going on, security was not on the top of the Gardner trend, but it again came back on top because what happens is that you cannot assume that the data is protected anymore. So you want to make sure that there are processes in place which actually make sure that the data is protected, the passwords are protected, and the passwords get changed regularly, as part of the product development. The signatures like which you are creating, like ID or the secret keys which you are creating, get invalidated regularly. How many times have you invalidated them in last year? Not regularly. We don't do that. But we should invalidate that so nobody else can bypass the security. How many here know that the default, for the routers, if you look at any router, you can find out the password for that router. You don't have to do anything. You go to any home, find out what kind of router they are using. I'm not saying go to any home, but I'm just saying you can try for your own home router also. You can hack into the router, you can change their password, you can do a lot of things, like which nasty stuff you can do. Yeah, so how is it possible? Because these are all open technologies, and then we have never changed our defaults. That's another problem. You're using Cassandra, you're always using the same port. Spark, you're using the same port. Change all the ports. That's perfectly fine. Why are you using the default ports? That is where the disaster comes in, like where somebody is looking for the port to be open, because if the port is open, doesn't matter, because the port 8080 is open. Port 80 is open most of the time. But if they know other ports which are open, which might be, they know which technologies they are using, there are tools available. If you just run through the security perspective, they can find out exactly what version of IIS you're using, what version of Apache you're using, what ports are open, how you can exploit these ports. Can you do SQL injection or not? Like, I have one talk where I actually do SQL injection on a SQL database and basically get the passwords out from there. So that's all possible just by hacking into any site, and you will be able, because all those ports are open for everybody to use. So that's the key part here, which is there. All right. So same thing is true with the code bases, like millions of lines of code which we are writing. So when we started today with the architectural characteristics, we looked at from the architecture perspective, like you have to look at the constraints and come up with the results. Think out of the box. You look at different languages. Don't just have Java or Groovy, but look at other language you have never learned before. Even if you don't learn it fully, it's going to give you a good understanding. Go and volunteer in a field you never have done that before. It's going to give you more wealth for the knowledge than you can actually learn from software engineering. That's another thing I can tell you. And then do lateral thinking. Why do I need 3 lines? I can solve this problem with 1 line. You can save 2 lines for yourself. For some other place, like I can reuse you. You remember that problem which I had. Same thing with paradox of choice. You have choices, give 2 choices. Use scrap as a model. Use the concerns which were there. We looked at the principles which we need to do. What are the different concerns which we need to have, and have visionary principles which you are working with. So I really enjoyed talking to you guys. If you have any questions, I am around.